Welcome everyone to this, our 14th Wednesday afternoon Canadian Association for the Club of Rome, and Wednesday presentations by our own members and guest speakers. Today we have a guest speaker, and Anitra Thorhaug, who is with the USA Club of Rome, and is I believe you're the chair of the
co-chair, yes,
of the USA Club, and her presentation is titled "Scrubbing Carbon from the Atmosphere Biologically: Blue Carbon as a Climate Change Solution." Would you go ahead, Anitra?
Thank you. So to get my thing up, do I do share screen again?
You do share screen, yes.
Okay, there we go. So I wanted to tell you, and hello, and thank you for allowing a lowly person from the lower part of the North American continent to address you. But at any rate, hello to all my KCOR friends, and hello to our board members, Van and Bobby, and hello to John. I want to tell you the big story, because I think if I get you involved in all the nitty gritty, that you're not going to remember all those numbers anyhow. But I want to tell you our solution, which we've been working on for several years, about taking the excess carbon, which is creating the climate change, and naturally, the way nature meant it to be, to put it back into the sediment. And the organisms that do that are called blue carbon organisms. It's tropical seagrass, and in the Gulf of Mexico and Southeast Asia, I'll tell you in a minute how and why we chose those two places. It's mostly mangroves, a very big tree, and seagrasses, which live from the intertidal zone down to the coral reef. And these are my co-authors, and some of the co-authors, I'll show you pictures of all of them at the end, but some of them are from Southeast Asia and others are from the Gulf of Mexico and United States. So how did carbon dioxide get such excess in the air anyhow? And here we have a fossil fuel plant. And of course, coal is much worse than oil, and oil is worse than gas. And of course, from vehicles burning their fossil fuel. And there are a few industries, such as cement industry, and in fact, some of the farming that's done, that also throws carbon dioxide into the air. Now, nature took care of that by having massive forests, such as the Canadian forests, which are truly some of the most massive forests in the world, scrub it by taking up the carbon dioxide from the air and combining it with sunlight and making more plant material. But it's become a great excess now, the carbon dioxide in the air. So a lot of it is being partitioned at some kind of rate into the seawater. The sea being, of course, 75% of the earth, and the terrestrial part about 22%, and then the lakes and the rivers, so forth, the bogs, the rest of it. This is a satellite map, sorry, and the blue represents the area where carbon dioxide goes down into the deep ocean. So our question here is, how does the ocean store carbon dioxide? And the red signifies the release of carbon dioxide, which, because of all the people's pictures, you can't see it, but it also takes it up in the mid-Atlantic equatorial area. So in other words, carbon dioxide enters the oceans from the Arctic and the Antarctic, It goes down very deep under the water and it comes up in the equatorial currents. So when I saw this, I realized, of course, this is blown by Coriolis force to the west. So all of this would, by natural forces, go to the west. I realized that there would be hot spots in the equatorial area. There aren't hot spots in the Arctic, and certainly not in the Antarctic, because there aren't any estuaries and any mangroves in the Antarctic. But of course, the temperate zone people rule the roost in terms of carbon and estuaries, and so they always have thought that they had the most blue carbon. But no, it seemed to me that these upwellings were going to be very important in the sequestration, which is what we call the burial down in the sediment of carbon. So we began looking at several places, which were the Gulf of Mexico and Caribbean Sea and the Southeast Asia region. Because on the theory, if you want water, you go to the waterfall, you don't go to the desert. So this is how CO2 moves around the oceans. The other was where it's absorbed. And the red is the heat machine of the ocean, and it's called the Great Conveyor Belt of the ocean by the oceanographers. So it comes up in the equatorial area, which we just saw on the last slide, of the Pacific Ocean, and it filters through all of these island archipelagos. Now, the interesting part here is that this is like a waterfall. There is a hydrostatic head between the Pacific Ocean and the Indian Ocean of about a half a meter. So this just comes pouring through all these little nooks and crannies between the volcanic island archipelagos of Philippines, Papua New Guinea, Indonesia, and parts of Malaysia like Borneo. And it goes around South Africa and it comes up and joins the mid-equatorial current of the Atlantic Ocean, goes through the Gulf of Mexico. Part of it goes all the way around the Gulf of Mexico, and part of it just goes past the tip of South Florida and over to Europe, which is why Norway is so warm and Ireland has palm trees. So the question is, I've got another, evidently, I'm going to take that off for 1 minute. I'm sorry, maybe we can. So mangroves take in sunlight, red light from the sun, and they take in carbon dioxide, and they pump through their extensive root system carbon down into the deep sediment. My colleague in Mexico has 10 meters deep, very, very thick carbon that he's pumping. And the seagrass take it from the seawater, dissolved carbon. They take it through their blades, and they're using blue and green light because that's what happens underwater. The red light gets filtered out, and they use blue and green light. And then they pump it down with their roots. This is how petroleum and oil was made in the beginning. And this is very relevant because what we're offering is a natural biological solution to this climate change. Some companies go to the wellhead and they grab the carbon dioxide as it's coming out of being pumped out of the bowels of the earth, and others go to the refineries and they grab the carbon dioxide, but they have to put them in canisters. What do they do with the canisters? They throw them in the bottom of the ocean and put cement on them and hope that they don't rust or in some way throw that carbon dioxide back into the air. But this is the way nature did it hundreds of millions of years ago, and I'd like to explain that to you. First of all, the seagrass and mangroves and other things throw detritus, the old leaves, the old blades, down into the estuary, and then that begins decay, and a lot more mud or sand goes on top of the organic matter. And then rock begins forming, sandstone or other kind of peat or muddy water. And so this gets pushed further and further under the water. And of course, we all know that there was this huge Tethys Sea that joined the United States and Canada, went up through Alberta and all those flatlands of Canada. And the ocean intruded there, and that's where a lot of the gas and oil of North America is, from Texas up into Alberta. So that made the layer of gas and oil. And finally, there was a lot of rock on top of this old detritus, and it separated into gas on the top and oil on the bottom. So what makes these two tropical areas important? First of all, 12 months a year, they grab the carbon dioxide out of the air and they stick it down into the sediment. Whereas in the Arctic part of Canada, there's a very short growing period, maybe 3 months, maybe 4 months. And in the temperate zone in Canada and the United States, the growing season is about 5 to 6 months. So you can well understand if you have 4 times the growing season or double the growing season, you're going to scrub a lot more out of it. However, I've just gone through a rather elaborate discussion about how the ocean itself makes a condensation of the CO2, and it throws it toward the western shoreline of the Pacific and the Atlantic. And this is a picture of Southeast Asia, and this is the Pacific Ocean coming into Southeast Asia. And you can see the currents. These are the major currents called by Klaus Wyrtki the flow through. And he did this just after World War II. I asked him why he did this, and he said, because Indonesia, which I went to get away from the crumbling wreck that was Germany, only had 2 things. It had a boat, and it had all this highly flowing current water. So I just went out and mapped the whole thing. At any rate, here's your flow through going from the Pacific down the hydrostatic head, down this waterfall over the Indian Ocean. And this is the geological part, which will interest Ted Manning and other geological types here. And it's called the Sunda Plate, which is a very shallow, very large plate going out. And on the edges, it has the ring of fire, which are all the volcanic tips of all these islands that have come up. So those 2 things together, the flow through of the hydrostatic head and the very shallow plate, make it an unusual place in Southeast Asia. Now here, if you look at another map, this is the mangrove map of Southeast Asia, and all these little green things are the mangrove populations. And you see that these islands here, the archipelagos, have a lot more mangroves than do the mainland, which is very interesting. So I said to myself, well, is this part of the flow through? Is it that they get more nutrient water? And that's why this is known as the Darwin line, where our friend from Britain, Darwin, went and found the maximum number of species of any place in the world, right coming through the middle of this. And of course, everybody thought life began there. That's why there's so many different species. But it may be that it's because there's so much nutrient enrichment between the flow through and the upwelling of the equatorial current. This is seagrass. And I want you to notice 2 things, the seagrass of the world. In Southeast Asia, you have a particular predominance of species and density of seagrass. And over in the Caribbean, you have a lot of seagrass also. So this was also fortifying my theory that you have this flow of the equatorial current, the flow through, and you get a lot of carbon distributed. This is the Gulf of Mexico that we looked at over there at the other part of the Atlantic, but you're all familiar with the Gulf of Mexico. Anybody in Canada spends part of the winter someplace around the Gulf of Mexico. And the red are the mangroves. And the water comes from the middle of the Atlantic, and it goes past the Greater Antilles, and it comes through this little hole between Mexico and Cuba. And part of the water goes clockwise around past Mexico, and another part comes past South Florida and goes up the coast to warm Newfoundland and goes over and warms Ireland, Norway, and all those coastal places in Europe. But what's interesting to me is that you have a predominance of mangrove right there where the flow-through water comes in, and also the tip of South Florida. The seagrass is a little green, and this is poorly made for the seagrass, but it's a little green in between. And the yellow is marshes, which you have throughout Canadian Atlantic. So I want to define Southeast Asia for you because we've been talking about it now. And basically, Papua New Guinea begins it, and it goes up to the Philippines. You go across southern China, Gulf of Tonkin, over to Myanmar, used to be called Burma, down the Andaman Sea, and take in all of Indonesia and a tiny bit of northern Queensland, Darwin, etc., Australia, and go back to New Guinea again. So we have spent decades learning how to plant seagrasses, much more difficult than planting mangroves. Mangroves have been planted for maybe 200-300 years, and they have a prolific fruit that hangs on the tree, and all you have to go, like apple picking, is with a basket and pick the mangrove and put them in a little nursery for 2 weeks, and then go out. And as I say, any fool can plant a mangrove. It's very easy, and they have 5-year-old children, and they have seniors out there planting mangroves, and it's been very successful. But this is me planting seagrass, which I was the first person to do very large-scale seagrass planting in the world. And this is my friend Jennifer Verdwin in Perth, Australia. And what she does, instead of planting them with little anchors on the individual plants, she puts 8 or 10 on an underwater structure that she buries in the sand and ties these on and puts them every meter. So here is a 6-month-old planting, here's a brand new planting, and here's a 3-year-old planting, and here's a 5-year-old planting. And she's doing it in the Indian Ocean, sort of in the center of Western Australia, and they've had extremely good luck. We're just coming out with a paper on Southeast Asia restoration. I came out with 25 co-authors, but a lot of Dutch workers about 4 years ago, and we looked at 2,000 restorations around the world and found out that many things about them, but there were very few done in the tropics, so we're trying to correct that. So here is both Southeast Asia carbon and some Gulf of Mexico carbon. This is my dear colleague Jorge Lopez Portillo, and we are indeed in the muck here, Helen Poulos, and we're wading through mangrove muck, which he's planted these mangroves next to a power plant. It's been very successful. And here is Wawan Keswara in Indonesia, and he has a big planted in Hallis patch here, and he's trying to see what animals have recolonized, what fish particularly have recolonized his restored. And then of course they've taken carbon in this, and we have taken carbon in this. And this is by Michael Yap from Borneo, a very productive place for. So, oh dear. So maybe I can, no, what's happened is for another presentation that had to be put in the can today also, we did slide by slide, and some of these slides have not been erased. I'm sorry, that voiceover. This is Gulf of Mexico, power plant where they did all the restoration of the mangroves. Jorge Lopez Putillo with a core, Helen Pulis with a core with me and Jorge standing by. And here's what a core looks like. This is before he planted the mangroves. So it's sort of gray looking sand. And this is after he planted the mangroves, which is black muck. And this is core is about 1 meter long. And here's, we're going through deciding on what place to get our cores, but you see how really big the mangroves are. And we got rid of that, sorry. This is Tim Koo's laboratory at Wesleyan University, Helen Pulis, and they are doing the chemistry, which involves quite a few steps and a lot of equipment. And these are the girls who did the work on the Gulf of Mexico. So this is, to me, one of the end products, and I know it looks confusing, and let me try to explain it to you, because once you know a little about it, it won't be so confusing. But if you only take 3 things home, you can take home the fact that all of these islands where the flow through happens are very, very rich in mangrove and seagrass carbon. And the mainland here, along between tropical China, Cambodia, Vietnam, Myanmar, Thailand, is relatively quite poor in carbon. So if you were going to scrub the world's atmosphere and oceans, you would take these islands where all the seawater is coursing through rapidly. Here, Indonesia, you have 2573 teragrams, which is really a lot. A teragram is close to a ton of carbon for all of Indonesia. And for the seagrasses, you have about 1/3 of that amount, 753. Now, Indonesia has the most seagrass in the world, so that isn't surprising that it has so much. One of the important things to realize is that the extent measurements, that is how much mangrove, how much seagrass, are very dependent on how good your satellite information is. And it's much better for the mangroves because they're organisms that live above the sediment. Whereas seagrass, because it experiences different color lights as it goes down, has been very poorly mapped, particularly in these Southeast Asia countries. So here we have a lot of carbon in Philippines, a lot in Papua New Guinea, a lot in Borneo. Here's the Gulf of Mexico as we're hopping back and forth, and you see all this nice green vegetative. In Yucatan, it's mostly mangroves. In South Florida, it's mostly mangroves. And you can't see from this satellite picture the seagrass, and that's the problem with most of these places and countries, that they don't have good extents of the seagrass. So what have we found out about blue carbon? Where are we? Well, we found out that in Southeast Asia, you have the most blue carbon in any of the regions of the world. You have about 5 million hectares of mangroves and about 6 million hectares of seagrass. But the mangroves are so productive of the carbon that you have twice as much mangroves, 3,000 teragrams of mangroves in all of Southeast Asia, and you have only 1,600 teragrams of seagrass. But that isn't surprising when you think of mangrove being a huge tree, 25 to 50 feet tall, and seagrass being a little plant under the water, which is between 6 inches and 2 feet. It isn't surprising that mangrove stock is much larger. But in the Gulf of Mexico, we have much less. We have about 1/10 as much mangrove carbon, 196, and we have about 20% of the seagrass carbon, 184, although there is double the amount of seagrass in the Gulf of Mexico as there is mangroves. So in the restoration, as I said, we're ready to go with this solution. And the solution being, how do we scrub maximum amount of carbon dioxide out of the air in the shortest amount of time so we can lower the world's temperature before all those glaciers melt on the mountains and in the Arctic and in the Antarctic. We have to bring the temperature down about 1.5, but we have enough, which I'm going to show you, we have enough space with just the mangrove and seagrass. We don't have to replant all the Canadian forests or all the boreal forests in Russia in order to do this. So the tropical seagrass stores a whole lot of carbon, and that can happen all over the world. And about 50,000 kilometers square have been killed of seagrass, and about that same amount have been killed the mangroves. So if we restore a large amount of this, this is going to be enough to bring the temperature down, according to Barry Hughes, who's gone through with his scenarios and models and found out exactly what you're going to have. So seagrass sequesters about 1 teragram per kilometer square. So 50,000, which is decimated by anthropogenic activities such as ports, dredging and filling of estuaries, making more land, runoff from the soil into the estuaries, sewage and other effluents, and mangroves have been destroyed, about 50,000 mangroves, and that's mostly from, in Southeast Asia, it's from making fish ponds, which is not a good way to make a fish pond by destroying the mangroves, but they've done that anyhow. But also mangroves are destroyed by any kind of shoreline activity, and we find that throughout the Western Hemisphere as well as Southeast Asia. So the rate of destruction, as calculated by somebody who has very good satellite data, works for NASA, is about 25,000 hectares per year, and the rate of seagrass destruction is 7% of the 171,000 kilometers square per year. So these are very, very steep destruction. But what happens when we put back the seagrass and the mangroves? Well, we get a lot of services free of charge. The fish come right in. And the fish, many of them are the nursery for the fish which you found in the deep sea, such as the shrimp, the crab, but also the kind of fish that artisanal fishermen right next to shore would eat and sell to the village to give good nutrition to the children. Biodiversity, such as the whooping crane's favorite food is the blue crab, that comes back. And a lot of other biodiversity, endangered species such as turtles and manatees and dugongs. Shoreline resilience, so the shoreline with the seagrasses in front of it erodes much less, and we see that in hurricanes in Texas. Mineral cycling and clear water. So these are the byproducts of the benefits. The one drawback, of course, is the amount of money it's going to take, but that means a lot of employment for village people, as well as scientists, of course, which I'm not shy about saying. What do we need to add to the science of carbon sequestered? Well, I think that we're shovel ready, as they say in the business. We're ready to go. We have integrated these large amounts of carbon data, and we've compared them among the Southeast Asian and the Caribbean and Gulf of Mexico. And this was at great labor because a lot of the data in Southeast Asia is found in literature which is in the languages such as Indonesian or Malay or Thai. And so we have many colleagues who have helped us find that literature. And it's much more in Southeast Asia than it is, as I said, in the Gulf of Mexico. Also, if you look at your other alternatives for putting carbon biologically in place, in Brazil and the other places where they have tropical forests planted, they burn down. Mangroves and particularly seagrass never burn. And also they have put this carbon into a safe, secure place, burying it under the sediment, just as nature did originally, making the fossil fuel that is such a problem. So we've looked at the stocks and the differences between Southeast Asia and the Gulf of Mexico, but it lacks one thing, which is the full depth of carbon. Most of these studies were only to 1 meter, and that's because the data reports it to 1 meter. My colleague in Mexico finds it down to 11 meters, and it's very ancient. It's thousands of years old. He can carbon date and radio date this. So these are lots and lots of numbers, and I'm mostly putting this here not to impress you with the numbers, but to say that this has all been worked out country by country, and in North American continent, state by state, and then Mexico. And we've gotten the satellite photographs and gotten exact extents, and we've gotten an average of a series of investigators' carbon data, and we've made averages for each of these areas, and then we've added them up. By the way, the Gulf of Mexico is much more extensive in carbon than the whole eastern seaboard of North America, which shows the hypothesis that the tropics are going to do a lot more than the temperate zone. So these are the seagrasses, and the extent in Indonesia is huge, and so is the carbon. I don't want you to try to memorize or even look at all these, but these are the detailed scientific numbers on which I make the generalizations that I've just told you about. These are the seagrasses in all the different Southeast Asian nations. And as I say, we did that in the Gulf of Mexico also, state by state by state. And these are the mangroves. Indonesia, of course, has 3 million hectares of seagrass and 2.7 million hectares of mangroves. So it's by far the mother lode of blue carbon and the mother lode of mangroves and seagrasses. But Malaysia, Papua New Guinea, and Philippines also hold their own. Some of the small places like Brunei, Singapore, the tiny tropical part of China don't do very well. So we're back here, and something like 85% of all the carbon is in these flow-through archipelago islands, such as Philippines, PNG, which is shared, of course, with Indonesia. So this is East Timor, and the Borneo Peninsula, which has 3 countries on it, and all of Indonesia. So our conclusions are very simple. This is a real solution. We have lost tens of millions of hectares throughout the tropical world of both seagrass and mangroves. They are very rich, fast growing, and very good sequestering of the carbon down into the sediment. And there are multiple areas throughout these countries, and in fact, the East and West African countries, in fact, some of the southern Middle Eastern countries, the Pacific Islands, and the Caribbean Sea in general, where one can do this restoration of the carbon to bring down the temperature. So this is our Gulf of Mexico group, and Jorge Lopez Portillo, Helen Pulis from the United States, myself, of course, and Jorge's team with Laura Dominguez Rodriguez, Helen And this is Barbara Carby from Jamaica, and Tim is behind, the chemist is behind everybody's picture. Graham Berlin from Yale, Arthur Schwartz, Hal Wanless, who's our sedimentologist. Barbara Carby is from Jamaica, and she's in charge of sustainability at the University of West Indies. Whoops. And this is our Southeast Asian team, Jennifer Verduen and Chana Prethep from Thailand. Jennifer's from Western Australia. Ansha Rapi from Northern Borneo. Wawan Kesara from the island of Java. John Barry Gallagher, who was in Borneo, who's now in Tasmania. Arthur Schwartz, Texas. Myself, Michael Yap, who also restores in Borneo. And behind all the people is Xiaoping Huang from the Academy of Sciences in China. So I thank you, and I want to leave you with 3 thoughts. It is possible to reverse temperatures. We have shovel-ready projects, and that is in the tropical part of the world, specifically Southeast Asia and the Caribbean Sea. We have all the species under cultivation that we can go and plant with villagers and skilled scientists as teams, and there'll be a lot of village work, and we're ready to go. It's the political will that has held us up now for about 3 decades, because the scientists are ready.
Okay, thank you very much, Anitra. The first question is, of course, from myself. I looked at your maps and, of course, your subsequent slides, and there's so many countries, there's so much shoreline. I mean, that's an enormous job to even categorize and collect data that says, are the mangroves good here, and the same with seagrass. How long have you been at this? It must be some time.
I was a very small child when I first began playing. You're asking my age. I never divulged that.
I'm sorry. I didn't mean
Naughty, Art.
Okay, we've got.
We've been at it for about 4 decades, doing the restoration. But mangroves have been restored for almost 200 years, so we know a lot more about mangroves than we do about seagrass, because seagrass is under the water; it's invisible. But the countries are very naughty about not having good graphics and plans. Only Philippines in Southeast Asia has a plan for their future of seagrass and mangroves. Only one country out of all those. And of course, the United States now has a plan. Even Texas is coming up with a master plan. Mexico doesn't yet have one, nor do most of the Caribbean countries.
Okay, thank you. The next question is from Zach Jacobson. Zach, go ahead.
Well, Ted already answered it. I wanted to know how, basically, how big is a teragram? You said it's about 1 million tons. And if you can take out 1,000 teragrams, is that 1,000 teragrams every year or what? That's sort of, a gigaton a year.
You know, I guess I planted more seagrass than anybody in a year or 2 years, and I'm able to plant 150 acres. I could double that, 300 acres, which would be 200, which would be 50 hectares. But there could be 8 or 9 big project areas around the world. The mangroves are much simpler and faster to plant because you go and you stick them into the ground, like you take a stick and stick into the ground, and you have little anchors, but they're much faster to harvest and they're much faster to plant. So you could plant any amount of mangroves. I mean, you could be planting 10,000 hectares, which they did in Vietnam. Remember, they used that Agent Orange, and then they defoliated much of Vietnam, and then now they've gone back and planted huge, vast areas in Vietnam very rapidly, very large. So you're saying, how long would it take us to put 50,000 kilometers square back? Is that your question?
Well, mainly really, that's a stalking horse kind of question. I'm trying to find out if this is the kind of power that's needed to take the whole atmosphere back down to 350 or even 300 parts of carbon dioxide per million.
Yes, I mean, it takes in a great deal, and there are calculations, and I can send them to you.
I wish you would.
And it definitely can scrub a very large amount. You can see that the mangroves are faster to plant, and they scrub about twice as much as the seagrass do. But that doesn't mean the seagrass aren't very valuable, because a lot of where the mangroves have been anthropogenically destroyed are shorelines where something else is substituting for it, such as a port or a village or a town or a city. And therefore, the seagrass are the middle of the bay. So there's not that much there unless there's a port and a channel. So there's much more space to put the seagrasses in, even though they only sequester carbon half as much. So you're going to have to look to the seagrass just for the sense of the space. On the other hand, there are all the shrimp ponds all over Southeast Asia where the shrimp have failed in the shrimp ponds, and they used to be mangroves. It's like some of the Canadian forests have been cut down, and nobody ever really replaced them 100 years ago, you know. So there are a lot of places you could replant the Canadian forests that are just lying there in ash or popple or something.
Thank you.
Okay, let's move on. Next question from John Meyer, and that's going to be followed by John Gilmore. John Meyer?
Yeah, Anitra, I really enjoyed this. It's something I've never considered, never heard of before. So it's fascinating. One of the things that you mentioned, the analogy to the Canadian forests, is interesting because 20 years ago, I was certainly one of the believers in replanting the Canadian forests as a way of mitigating some carbon emissions. But in the last 20 years, since around 2000, the impacts of climate change have actually made the Canadian forest a net emitter of carbon. In some years, it amounts to more than, in fact, double what we emit from the oil sands. So I just wonder is that same impact being felt in the oceans with the seagrass and the mangroves? I mean, look at the Russian permafrost now in the Russian forests. There's a huge emissions now because it's of the heat. Are the oceans being affected, the plants that you're working with, are they being affected by acidification of the oceans, or are they able to do their job in the face of the impacts of climate change?
That's a very astute question and a very technical one. First of all, seagrasses we haven't found emit carbon, and we haven't found that they age in the same way that mangroves do. Mangroves do emit carbon, not as much as boreal and subboreal forests, but as they reach their expected life time, then they're microorganisms that come and decay them. Of course, if the wood choppers have their way, then they chop them down for firewood and so forth. And these are very densely populated areas frequently with the mangroves, especially Southeast Asia. But yes, there is some emissions of carbon dioxide from the mangroves, and that hasn't been quantified yet. And obviously you have to do a balance, some kind of chemical balance.
Okay. Okay. One supplementary question here. Don't want to take up all your time, but when they looked at embedding carbon in soils, farm soils, forest soils, this kind of thing, they found, the only study that I saw of it in Sweden was that you could implant carbon in the soil, but it reached a level that, well, it hit a ceiling. And I'm just wondering if there's any kind of density ceiling for carbon in the mangrove and seagrass swamp, the goop that you mentioned, or can it just keep on absorbing? Does the roots go lower, or does the material just keep on building up?
Yeah, I think it depends where you are, because some places are very, very rapid accumulation of sand and mud. And in some cases that all gets swept out with the hurricane, and in others that gets filled over and starts being a beach rock and other forces which keep all the carbon dioxide down. Like I showed the illustrations of the rock, the rock coming on top of it. With seagrass, it's a different question. The seagrass builds up to a foot a year, and some of that in the very heavy storms gets washed away out of the estuary into the deep sea, but others once more get under the beach rock and are fortified so it doesn't come out, and it does cavitate down into the sediment. You know, there's a concentration gradient down into the sediment, so there's a migration downward.
Okay, great, thanks.
Okay, and our next question from John Gilmore. Go ahead, John.
Thank you. And Anitra, this is such an obvious and this is such an obvious and logical solution. Why do big governments and corporates and funders not buy into it as at large scale? What do you think the reasons are?
I think the rules and enforcement are not adequate. They began by saying if you take so much shoreline or so much underwater, then you put down 2 acres for every one you take. And they should have been talking about 20 acres for every one they take. And that very small enforcement worked very well. But why states or nations don't have a long-term plan and say we've lost 5,000 kilometers square and now we want to put that back in Brazil is beyond me. They have plans for everything else, for their economic development, for their social development, but they have no plans for their putting back the resources that they've lost. So it's a question of political will, which is beyond my understanding, except for the fact that it involves money and it involves all kinds of political forces which have never been interested in the environment. You know, it's much better to do another 10 power plants right on the shoreline and dump your heat than it is to put in hundreds of acres of seagrass. I know that's a poor answer. I would like a very elegant answer, but it's all politics. The scientists are ready, shovel ready to go.
Okay, thank you, Anitra. Vic Buxton, do you have your question, or has it been answered now?
No, not quite. Basically, my question was a bit more specific. I was just wondering, and I've been involved in the negotiation of a lot of environmental treaties, and climate change is not one of them. But my knowledge of the IPCC and what it writes about is all of the destruction of the atmosphere, but very little in the way of proposals for mitigation. And I wondered why, when they have climate change convention meetings, people aren't coming out with proposing these very, perhaps really low-cost solutions. The problem has to be addressed in a global context. And under the Montreal Protocol for Protection of the Ozone Layer, we created a multi-billion-dollar fund to help developing countries do what they could. And this looks to me like you could assign credit to other countries for assisting where you can grow mangroves and seagrass to mitigate the effects in a global context. It's a logical step forward. And I wonder why the absence of this? Because it doesn't take a lot of politics to say, geez, this is the least cost alternative, probably. That doesn't mean you don't have to reduce fossil fuels, but it just means that it's risk reduction in a major way.
Yes, it is big risk reduction, absolutely. And second, it's fairly cheap. I mean, you can plant mangroves and seagrass for about $10 per unit, and in developing countries, you can do it for about half or a third of that cost. And it means a lot of employment, and it means a lot of benefits, fish and wildlife and clear water for tourism and so forth. So I agree with you. The price is very cheap. It's a secure burial. It doesn't burn. It has, at least the seagrass, minimal emissions backward. So there are all these benefits, including the price. And
well, the logic to me in this one is that you can assign credits to countries. Right now, countries are backing away from the Paris Accord simply because they can't meet the obligations under it and they don't want to be Paris-fied. But if you gave credit back to these countries that they do their best in terms of emission reductions globally, or locally, but contribute globally to the mitigation of the problem, then this I think behooves all of us to encourage this kind of behavior.
yes, I'm agreeing with you.
Okay, we have John Meyer with another question. Go ahead, John.
Yeah, it's more of a speech than a question. I just wanted to say that the question came up of politics, and it's because of politics that something didn't happen. I think it's more corporate interest. You can live extremely well if you're at the top of the pyramid for power plants and this kind of thing. They're very concentrated generators of wealth. If you happen to be the one pushing thousands of hectares of seagrass or thousands of individual projects of seagrass, there's no way that anyone can make an extremely lucrative living out of that. So it doesn't get funded, it doesn't get the interest, and it probably gets a lot of opposition who have a vastly more profitable, not politically motivated, but profit motivated reason for wanting to do things in a different way. So that's it's a question. If you want to treat it as a question, go ahead, but that's my interpretation.
Well, Florida has initiated an interesting program, and that's that anybody can go out, get the permits, and start planting at their own expense, and then they can sell this mitigated area to large infrastructure such as roads department or power plants and so forth who need mitigation. So it's a bit entrepreneurial, but very few people are taking it because it's all that upfront money for not a very secure future. The same with carbon credits, and the carbon credits they've made extremely hard to monitor. So it sounds wonderful that a power plant would buy so many mangrove or seagrass carbon credits, but they've made it so expensive to monitor that only 20% of the costs of the planting and the monitoring come back to the vendor who does the planting.
Wow.
And that's simply an overlay of a very intrusive government.
Okay.
Okay, and next question from Ted Manning. Ted?
Yeah, I was going to react that at the discussions on the UN goals in Morocco a few years back, seagrass was not mentioned, but mangroves were extensively mentioned in the section dealing with tourism coastal zone development. And they actually do have some goals and indicators in place that countries can use. The tourism sector has started to invest in mangrove preservation for really two reasons. One is that they can sell tours. The one behind me on my screen is one in Sri Lanka, where extensive mangrove tours are taken, and they've been actually paying the people to enhance them. Similar things are happening in Kenya and in Thailand, because that industry realizes it can protect its shore zone or protect its riverine edges, as well as making money selling people to see them. Seagrass is going to be a tougher sell. And in fact, there did not appear to be knowledge of or interest in seagrass, even mention, don't even, certainly sessions I was in, were trying to develop ecological indicators for shore zones and for tourism areas. Seagrass was never mentioned by anyone. So it probably needs a better sales job, and I'm not quite sure how that's going to happen.
I think coupling it with coral reefs, because there are a whole lot of animals that the seagrass and then go back to the coral reefs for protection at night. There's a day back and forth, and coupling that with keeping your coral reefs healthy is one of the few, because there's big money in coral reefs for tourism, you know.
Oh yeah, tremendous amounts. I mean, I was paid under the counter by Americans to help Cuba save its reefs, but trying to get money for other things are rather difficult. And yet, well, the U.S. government has a lot of money in it. So do the French. So do others. There are big projects in reef protection in Hurghada, in Cuba, in Costa Rica, in all over the world, and certainly a lot of money going into the Great Barrier. So maybe you do need to make them part or market them as part of the same ecosystem.
Yes, I think you do. And I had the plan a couple decades ago of putting out large seagrass mitigation and having artificial reefs in the middle of them, and including reefs that were made like the Japanese do for certain gravid or pregnant females of the edible species such as lobsters, crabs, and other things. So you could make little cubby holes for them, so to speak, in this artificial reef, and then they go out on the seagrass flat. And all of this could be done from barren areas and up the fisheries productivity as well as snorkeling.
Great. Good luck.
I do recall taking a mangrove tour in Florida, and with an old alligator that lurked in there as well, and that was a very worthwhile tour. Anyway, the official count of questions has come to an end. There's none waiting here, and at this stage I will cease the recording, and we would then go to an open session, and everyone can turn their audio and their video back on.